Hello everyone, I'm Abhas, and with me here today is Team 17962 Ro2D2 from Romania. They have been absolutely fantastic this season, having their first qualifier just a couple days ago and taking home that Winning Alliance captain title after a max non-penalty score of 280 points. Today in their Behind the Bot, we're going to jump into their intake, deposit, and past iterations they've had, including a completely whole different robot. All this and more coming up on First Updates Now.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. Check out our all-new FTC content coming to Fun's YouTube, including new hosts from the FTC community. We'll have resource guides, top 10 moments, behind the bots interviews, and walkthroughs to help your FTC team improve at youtube.com/firstupdatesnow.
Okay guys, let's get started with your intake. It is definitely a lot of degrees of freedom, but you guys have managed to make it work together very, very well, very efficiently, and it just seemed to never break during competition. So let's walk through the hardware first, and then we'll talk about some of the sensors and software you guys have.
Hi, yeah. For the intake, we didn't actually have so many degrees of freedom in our first iteration. One of the degrees that we added later was this one, which really helped us actually pick up cones from the stack without making it fall, because our pivot point for the virtual 4-bar is a bit too low, and so when we go for the first cone in a stack, we have a horizontal component to the movement, and if we don't move the angle of the claw, it actually falls off. And also because of this this degree of freedom, we have a bit more range when we deposit our cone on the passive outtake, so we can do it like this.
Yeah, that's fantastic. And so can you give us an overview of like how your intake works? I see you guys have a slide system, and then an arm, and a claw, and the pitch control, as you said, and the turret. But if you could just talk about each part a little bit more. Let's start with the slides.
Right. So we do use a linkage for extending the slides, because we thought it would be just much faster. We have like a quarter of turn for
and they fully extend in less than 0.2 seconds, but they have a fall because we don't have intermediate positions. We can only fully extend them or retract them, because the motor revolves too little for it to have enough power to hold that position because of inertia.
Yeah, so as you would probably think, we don't have precision because of this like quarter turn. So we do use a rev through-bore encoder on the axle to have a bit more precision on it and actually be able to make the pit work.
Yeah, and so is this linkage powered by a motor or a servo, or what ratio motor are you running for that? Because motor powered linkages are definitely something that are not as common as servo powered linkages.
Right, so we do have a belt transmission right here with a 117 RPM motor. I think.
It's an 84 motor. We had a 117 motor initially, but when we switched it to an 84 because we thought that it would help us hold the position, we had a lot of faults in our first iteration because we don't have 117 RPM motors on hex. We don't have the pulleys, and like you can see it, but we actually had to drill through a pulley on our first iteration. And to make everything fit nicely, we had to switch to an 84, which didn't actually impact our intake very much, so we just rolled with it.
Yeah, and so like another question I have about your intake extension specifically is we've seen a lot of other teams that have like this horizontal extension, and about as long as reach as yours, they decide to use string instead, and like a string and pulley system. Is this something you guys are considering switching to for the Romania National Championships, or is it like this works really well, there's no need to change it, let's focus on other parts of the robot?
Yeah, well, one of the big disadvantages of the linkage is that you cannot actually have more Misumi slides one after the other, because you're only extending the extremities.
And right now we are using a 3-stage, and we are probably going to add one more 2-stage or two stages.
Yeah. So we are very much considering string extension for the intake as well.
Sure. And so now talking about your intake arm, I see you guys have like 2 servos there, and then it looks like you have some sort of linkage system. So walk me through that, and any struggles you've had with it or any advice you have for teams.
Right. So we are actually using Axon servos for our virtual 4-bar. And these are just lifesavers for our cycling time, because we have like a 0.18 seconds from collecting the cone to actually depositing the wheel. It's extremely fast, and we are also using springs to hold the position for our stack autonomous.
And also to put less strain on the servos, because we use GoBuilda torques, and they worked really bad for us.
So
Right. And
yeah, and so with that, you guys are using the servo like through a gear train to rotate the arm, and then the spring is just for counter spring. Like it's not a linkage or anything
Yes.
like that.
Yeah.
Okay. Okay,
We
I
are
see.
using a 1-to-2 gear ratio right
Uh-huh.
now, but we are planning to change and use 1-to-1.
Okay, wow. Yeah, no, that's fantastic. And so your pitch servo was like your most recent addition to your intake, right? And so were there any challenges you've had with that? Like have you had issues with like the belt skipping, or would you prefer to go with chain or anything like that, or has it worked out really well?
The biggest problem we had with most of our collection system was the fact that we had 3D printed gears right here, even for the angle of the claw, and these would get worn out real quickly, because as you saw in our autonomous for the regionals, we would really just bang into the wall to make sure that we had the cone in our claw. And I think right before the regional championships, like that morning or in that night, we had a problem where these two gears would skip because they were worn out, so we had to change them. These are not actually ours. We actually had I say we had a feeling that something would go wrong, and we asked teams in Romania to borrow us some, and we're planning to buy them and like give them back. But yeah, these actually saved the season for us, because we wouldn't have had the exact positions on them.
right, and we also had some like a lot more aggressive weight reduction on these bars for the bar, because at first we were considering also trying with speed servos from GoBuilda before going for axons. So they would actually bend very easily here.
Oh man.
And
Wow.
we had to redesign them for better stability.
And one time we inversed the servos, and they bent really bad, and we couldn't use them anymore.
Also, another thing that we had to go through was the fact that we didn't realize on the project that the cone would hit. So this part was doubled here for stability, and we didn't realize that the head of the cone would hit this part when rotating. And we were actually really lucky to see that in a demo, and we just removed it, and now everything goes smoothly.
On
Okay.
the turn.
Yeah.
Yeah, and so talking about your claw a little bit, how did you go about designing it, and how has it worked, and are there any changes you'd like to make for the national championships?
Well, we've had a lot of claw iterations for our first robot for the double reverse 4-bar, but one of the biggest challenges with this robot was actually making it small enough to fit through the virtual 4-bar with the cone. So we are using like herringbone gears right here, and yeah, it's just very low profile to fit
Yeah,
through the
and
virtual 4-bar.
we tried silicone on the claws, but I think we didn't implement it correctly, because we didn't realize that we needed some pockets. So we just went with some store-bought Keller for our intake. Something store-bought.
Yeah,
Sure.
we also had a pretty weird idea on our first bot
Yes, on that.
with this flexible claw right
That
here.
was picking the cones like that. I can do it because we don't have Kedder on it, but you get the idea. And after simulating it on SolidWorks, we discovered that after many uses it's going to break in a lot of points because the factor of safety of the simulations was below 1.
Uh-huh. Got it. And so, yeah, let's jump into your transfer before we go on to your deposit. So, how do you guys transfer the code, and what are some things that you've done to your transfer to make it much easier and much more consistent?
Right. So our first iteration of our transfer actually had a linkage that would oscillate between like a transfer position and a deposit position,
Mm-hmm.
which was actually very detrimental for our cycle time, and the complexity of it made it very hard to actually synchronize all of them, and we broke it like a, a couple of times because we extended our deposit on the claw.
Mm-hmm.
Uh, and so this was back when we had an illegal deposit system with our V guide, and the way that we made the deposit system stationary was by adding this degree of freedom, which allowed us more range on depositing the cone. So we didn't have to oscillate between transfer position and deposit position. We could just make it stationary. Like that.
Sure, sure. And so, like, what is the profile of your guys's like deposit, and like how has it changed throughout the season?
So here it is right now. It's like the most changes came to the guide right here, which
Mm-hmm.
was I don't think I actually have the prototypes.
Yeah, so like we have the prototypes for the guide right here. So like the first one, we knew that this was illegal. We just made it for tests so we could test the idea and that it worked properly. And then when we found out about the rules, so we couldn't use the old one
Mm-hmm.
with the guide for the cone, we realized that we needed something. So at first, with the radius, we knew that we couldn't place it on something stationary. So we had to place like when it was in the air, when we were trying to score, we knew that it wouldn't have anything under it to support it. So if you give me the cone, we had to implement like a safety.
Mm-hmm.
You see this pushes the cone up front, and it pushes it against this little lip.
Sure.
And for the when coming back to the guide, we first implemented after the rule. We thought that a V with a with like where the 90-degree angle was replaced with a single arc would be fine. Then we found out that it wasn't fine, and we didn't even have that for the grace period. So we just made an arc that was barely larger than that of the cone, so we
Mm-hmm.
wouldn't sacrifice performance, and it would also be consistent with the pole.
Yeah, and we also have an additional platform right here for supporting the cone when like right after the transfer. So
And
Okay.
also some problems in a demo because some cones fell into our robot, so we made that plate in order to not get cones stuck in our robot.
right, and we also have this plexiglass ramp, so in case some of the cones get uh, lost,
Of
they
course.
can just.
Yeah, they just roll right out. Yeah, and so let's talk about your guys' linear extension for the deposit. And from my understanding, you guys are very special in the fact that you were able to develop two robots side by side. So why don't we focus on the first version of your linear deposit, or of your of your deposit system that you guys have, and then we can talk about why you switched over to this design.
Right. So, firstly, we actually designed a double reverse forward robot, which as you can probably see for the more experienced teams, is highly influenced by the gluten-free design in Skystone with the linkages here. We have 43 RPM motors, two 43 RPM motors, which extended in about zero point 0.3 seconds to full extension, and it's almost completely 3D printed for a lower weight, and we have a lot of like optimizations here for you know
For the
stability.
forceability and weight reduction.
Mm-hmm. Yeah, and so what convinced you guys to switch from this design into the linear slides extension system that you have right now?
We have actually had a lot of difficulties with the first design in our autonomous periods. We would get 5+1 autonomous, but not very consistently because of the long travel time between cones. So we knew we had to make something that had a little bit more range. So this was very good in teleop because we didn't have any kind of transfer. We just picked up the cone and lifted it up, and we did have a lot of driver practice because we went to demos with our first robot for about 3 months or so, and it worked really well. It just wasn't very consistent in autonomous.
And one concerning problem about the double reverse four bar system is the fact that it's a very high maintenance system. Because as you can see here, even though we went to like 3 iterations for the arms, after a month of playing with it, it eventually broke down. And we used something like when you break your arm. I don't know how it's called in English.
A cast.
A
Yeah,
cast,
a cast.
yes, a
Yeah.
cast. And we replaced them at 3 a.m. before a demo contest.
Yeah,
It was quite an experience. And some parts break, and it's very hard to assemble the whole assembly with the gears and the pulleys there.
Yeah, the
Okay.
linkages and the gears and everything. So
If
yeah, that's
something breaks down, it's very hard to repair it. So in case this robot would break before a match, we would not be able to compete because
Sure.
we couldn't fast enough to repair it.
sure. And so now talking about your current deposit with the linear slides, walk us through that very quickly, and then we can talk about your guys' driver strategy and practice system overall.
So for our deposit, the thing that we wanted to improve the range that we had when we deposited. So with the double reverse four bar, the biggest concern in autonomy was the fact that I had the error that I had was the range of the cone. So the inner radius of the cone was how much I would have to place it on a junction. So I needed something like a guide. And like you would see that as well in the Peppers robot, or right now Rescue is competing. They would have a guide, so they would push the pole, and probably that would have worked as well for the double reverse four bar. But then you would have the other problem of time, going from the junction to the stack. So right now with this deposit, I have a larger range of error, and I have more positions from where I can deposit the cone. And also with enough speed, I can always center the junction right under the cone. So that is perfect for me in autonomous because on the self autonomy that we use, we really have a huge range when it comes to our X position on the X axis. Like I have this much range, so about like 3, 4, 5 centimeters from where I can deposit. So that worked wonderful in autonomous.
Yeah, no, that's fantastic. And so looking forward to the Romania National Championship, I'm sure you guys want to take home that Winning Alliance captain title as you did at your qualifier. So what plans do you guys have to do that? Is it just going to be a lot more driver practice? Are there any robot changes you're planning, or are you not quite ready to reveal them?
Right. Well, we are going to make our transfer time and our cycling time a lot more efficient, and we're probably going to work on making our deposit faster with different motors, and probably going to string extension on our intake as well.
Interesting. Yeah. So, Ro2D2, thank you very, very much. This has been an extremely informative interview. I'm sure teams have a lot to learn from how you manage your intake and all those degrees of freedom to developing 2 different robots at the same time. So, reporting for first updates now, I'm Abbas, and with me here is Team 17962, Ro2D2. Thank you, everyone.
Thank you.
Thank you.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. Check out our all-new FTC content coming to Fun's YouTube, including new hosts from the FTC community. We'll have resource guides, top 10 moments, behind the bots interviews, and walkthroughs to help your FTC team improve at youtube.com/firstupdatesnow. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.